بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 3.6. So we will solve some exercises about it. We studied in this section how to find the derivative of the logarithmic functions and also how to find the derivative of the inverse trigonometric functions, sine inverse, cosine inverse, and so on. And also we studied how to use logarithmic differentiation. Um, Here, differentiate the function. So this is a logarithmic function. So the definition or the derivative of the logarithmic function would be f prime of x would be 1 over x squared plus 3x plus 5 times the derivative of x squared plus 3x plus 5, which is 2x plus 3. So that's the derivative. So the formula is d by dx for len u is u prime over u. Here we have product between these two functions. So f prime would be derivative of x is 1 times ln x plus x times the derivative of ln x, which is 1 over x, minus the derivative of x, which is 1. So the answer would be ln x plus now x times 1 over x is 1 minus 1. So the derivative is equal to ln x. Here we have a composition between two functions. So the derivative would be derivative of the outer function, which is sine, so cosine at ln x times the derivative of the inner function, which is 1 over x. So I can say that cosine ln x over x, that's the derivative. Here we have composition. So f prime of x would be derivative of the outer function, which is len, so 1 over sine square x times the derivative of sine square x, which is 2 sine x times cosine x. Notice that sine square x is sine x all to the power 2. So when you find the derivative, you use the chain rule, power rule. 2 times sine x to the power 1 times the derivative of sine, which is cosine. Now I can cancel sine with one of the signs below, and the answer would be 2 cosine x over sine x. I can leave it like this, or we know that cosine over sine is just cotan x. Here I have len. I can find the derivative immediately, or I can use the properties of logarithms to expand this. So this is division. Len u over v equals len u minus len v. So len 1 minus len x. But len 1 is 0. So in fact, f of x is negative ln x. So f prime of x would be negative, and the derivative of ln x is 1 over x. Now here I have 1 over ln x. You can write it ln x to the power negative 1 and find the derivative, or you can use the formula. We know that d by dx of 1 over u is negative 1 over u squared times u prime. So that's the derivative of 1 over u. So y prime would be u squared ln x to the power 2 and negative u prime, the derivative of ln x, which is 1 over x. So I can write it negative 1 over. This x will, it's already down below in the denominator, times ln x all square. This would be the derivative. I have here composition. So g prime of x would be the derivative of the outer function, which is len. So 1 over x times e to the power negative 2x times the derivative of the inner function, which is a product of two functions. So we will use the product rule. Derivative of x is 1 times e to the power negative 2x plus x times the derivative of e to the power negative x is e to the power negative x times the derivative of negative x, which is negative 2. Remember, the derivative of e to the power u is e to the power u times u prime. So the answer would be, notice I can take e to the power negative 2x as a common factor in the numerator, okay, from the two terms in the numerator. So I'll have 1, and here I'll have minus 2 times x over x e to the power negative 2x. Now I can cancel e with e, and the final answer would be 1 minus 2x over x. I have a square root, and we know that the derivative of square root of u is 1 over 2 square root of u times u prime. So g prime of t would be 1 over 2 times square root of 1 plus ln t times the derivative of 1 plus ln t. Derivative of 1 is 0. Derivative of ln t is 1 over t. This t is already below, so I can write it 1 over 2 times t times 1 plus ln t, and this is the derivative. I have here product, okay, product of two functions. So if capital prime of t would be, I use the product rule, derivative of the first function, 2 times ln t to the power 1 times the derivative of ln t, which is 1 over t, times sine t, plus the first function, which is len t to the power 2, times the derivative of sine, which is cosine t. Okay, and that's the answer. I can write here t below. It's okay, I leave it like this. I have composition here. So p prime of t would be derivative of the outer, which is len. So 1 over square root of t square plus 1 times the derivative of the square root. Well, let me do it alone. The derivative of the square root is 1 over 2 times the square root times the derivative of t square plus 1, which is 2t. This 2 cancels with this 2, and I'll have t in the numerator. And if I multiply these two roots, I get rid of the root, and this would be the final answer. I have a composition here, y prime would be. Let me remind you with the rule, d by dx of log u to the base b is 1 over u times log b times u prime. So I'll have x squared plus 3x times len 8. It is len, not log. Okay, the formula is u times len b. So, and here you write the derivative, which is 2x plus 3. So this would be the answer. Well, here I have composition. Y prime would be the derivative of the outer function, and I use the same formula, this formula. So it is 1 over secant x times len 10. And here I have the derivative of secant, which is secant x tan x. Now I can cancel secant with secant, and the answer would be tan x over ln 10. Here I have composition. So the derivative of the outer function, this is the outer function. The derivative is 1, if it helps you to write it like this, it's okay. 1 over ln s, okay, times the derivative of ln s, which is 1 over s. So the final would be 1 over s ln s. That's the derivative. Here I use the quotient rule. 1 minus v all square. Derivative of ln v is 1 over v times 1 minus v minus ln v times the derivative of 1 minus v, which is negative 1. Now to get rid of this v, I will multiply by v over v. All right. So I will have 1 minus v, and this minus times minus is plus v times ln v over v times 1 minus v to the power 2, and I can just leave it like this. Here I have product. So t prime of z would be equal to the derivative of 2 to the power z is 2 to the power z times ln 2 times the second function, which is log z to the base 2, plus the first function times the derivative of the second. Derivative of log z is 1 over z times ln 2. So that's the answer. Well, here I have ln, all of this. I can start by simplifying, expanding the logarithmic function. If you expand the logarithmic function, so you have ln, the numerator t times t squared plus 1 to the power 4 minus ln, the denominator. And then here you have product. So you can write it ln t plus ln t squared plus 1 to the power 4. And I can write this 2t minus 1 to the power 1 over 3, the cube root. And now I can write it ln t. I can take the 4 outside below. So 4 ln t squared plus 1. And I also can take the 1 over 3 out, 2t minus 1. So here we used the properties of logarithms. We know that ln u over v equals ln u minus ln v. And ln u times v is ln u plus ln v. And ln u to the power r is r ln u. And now this is g of t after expanding. So it's easy now to find g prime, the derivative. Derivative of ln t is 1 over t. Here, I'm using this one. Derivative 4, I have 4. And the derivative of this is 1 over t squared plus 1 times 2t minus 1 over 3 is constant. 1 over 2t minus 1 times 2. So I can write it finally 1 over t plus 4 times 2, 8t over t squared plus 1, and here negative 2 over 3 times 2t minus 1. That's the derivative. Here I have an absolute value. Remember, we said that d by dx of ln absolute value of u, okay, is u prime over u. So the derivative y prime would be 1 over 3 minus 2 times x to the power 5 times the derivative, which is negative 10x to the power 4. That's the derivative. Okay, so the absolute value here really uh, just keeps what is inside len positive, but the derivative you write it like this. Well, y prime here, this is a composition. So the derivative of the outer function, which is len, so 1 over cosecant x minus cotan x. Okay, and now the derivative of cosecant is negative cosecant x cotan x, and the derivative of cotan is negative cosecant square, and there is a minus here, so it would be positive cosecant square x. Well, this is cosecant, okay? Cosecant x, cotan x. I can take cosecant as a common factor, okay? So taking cosecant as a common factor, I'll have negative cotan x plus cosecant x over negative cotan x plus cosecant x. This is, you can write it cosecant negative cotan or negative cotan plus cosecant. They cancel, and the answer is cosecant x. So the derivative of this is just cosecant x. Again, I have a composition. So y prime would be 1 over times the derivative of this. Derivative of e to the power negative x is this one. And now here I have product. Derivative of x is 1 times the derivative of e to the power negative x, which is this one. Okay. Notice I have here negative e to the power negative x plus e to the power negative x. They cancel. So finally I have negative xe minus to the power negative x over. Notice I can take e to the power negative x as a common factor from the denominator. And I can cancel e with e, and the final answer would be negative x over 1 plus x. Here g prime of x would be derivative of e is e times derivative of u, but it's a product of two functions, so I'll use the product rule. Derivative of x squared is 2x plus x squared times derivative of ln x, which is 1 over x. So the final answer would be x squared over x is just x. Well, here h prime of x would be e, the derivative of e to the power u is e to the power u times the derivative of the u, the power. Derivative of x squared is 2x, derivative of ln x is 1 over x. Here I will simplify first, I will expand. So I will write it ln 1 plus 2x over 1 minus 2x to the power half. And then I'll take the half out, okay? And after I take the half out, I can write it ln 1 plus 2x minus ln of 1 minus 2x. And now I can find the derivative. The half is a constant, and derivative of ln 1 plus 2x is 1 over 1 plus 2x times 2, the derivative of 2x, minus 1 over 1 minus 2x times negative 2. So I can write the answer as, if I multiply half times this, I'll have 1 over 1 plus 2x, and this is a plus 2 times half, so I'll have 1 over 1 minus 2x. So that's the derivative. Here also I will simplify first. I will expand. I will write it ln x to the power a minus ln b to the power x. Well, now I can also write it a ln x more expanding, minus x times ln b. Now the derivative is derivative of a times ln x. A is a constant. Derivative of ln x is 1 over x minus. Notice that ln b is a constant. So you just write it and find the derivative of x. Derivative of x is 1. So that's the answer. So the answer is a over x minus ln b. Notice that if I ask you to find the derivative of 3x, you will say 3. Derivative of square root of 2x, you will say square root of 2. Derivative of pi x, it is pi. Derivative of ln2 times x, ln2, and so on. So you keep the constant and you find the derivative of x simply. So derivative of lnb times x would be just the constant lnb. All right. 26. Well, here we have composition. So we find the derivative of the outer function, 1 over x log x to the power to the base 5 times ln 2 over the derivative of the inner function, which is a product. The derivative of x is 1 plus x times derivative of log x to the base 5 is 1 over x ln 5. That's it. Now x cancels with x, and I will have log x to the base 5 plus 1 over ln 5 over x log x to the base 5 times ln 2. Now to get rid of ln 5, I can multiply by ln 5 over ln 5. So I will have ln 5 times log x to the base 5 plus 1 over x ln 5 times ln 2 times log x to the base 5. And I can leave it like this. Here find the first and the second derivative. Well, the first derivative is 1 over secant x times the derivative of secant x, which is secant x tan x. And secant cancels with secant, so the first derivative is tan x. The second derivative, derivative of tan, is secant square x. Let us find f prime of 1. To find f prime of 1, I need to find f prime of x first. And if x is a composition, so the derivative is 1 over the inner function times the derivative of the inner, which is 1 plus ln x derivative is 1 over x. Now I need to find f prime of 1. So just replace x by 1. 1 over 1 is 1. 1 plus ln 1 is 0. So the answer is 2 over 1 or just 2. Here also, f prime of x is, this is a composition. The derivative of the outer function, which is cosine, is negative sine ln x squared times the derivative of the inner function, which is ln x squared. Well, let me first simplify. I can find the derivative, but I like to simplify the ln. Whenever I have ln x squared, I can write it as cosine 2 ln x. And now f prime of x would be again negative sine 2 ln x times the derivative of 2 ln x, which is 2, times the derivative of ln x, which is 1 over x. And let us find f prime of 1. Well, it is negative sine of ln 1 is 0, 2 times 0 is 0, sine 0 is 0, times 2 over 1. So 0 times 2, the answer is 0. Find an equation of the tangent line to this curve at the given points. Well, the equation is y minus 0 equals y prime at 3 times x minus 3. That's the equation of the tangent line. And to find y prime of 3, I find y first. I have a composition, so the derivative is 1 over x squared minus 3x plus 1 times the derivative of this, which is 2x minus 3. And now to find y prime of 3, I replace x by 3. 2 times 3 is 6 minus 3 is 3. 9 minus 9 is 0 plus 1. So it is 3. The slope is 3 and the function is y. The equation of the tangent line is y equals 3 times x minus 3. You can leave it like this or you can write it 3x minus 9. Same question. The equation of the tangent line is y minus 0 equals y prime at 1 at x of x minus 1, x0, which is 1. Okay, I need to find y prime 1. So let us find y prime. This is product. Derivative of x squared is 2x times ln x plus x squared. Derivative of ln x is 1 over x. Now y prime of 1 would be replace x by 1. Ln 1 is 0, so this would be cancelled. And this is x squared over x, which is x. So if you replace it by 1, you have 1. So the equation is y equals x minus 1. This is the equation of the tangent line. For what value of c is f prime of pi over 4 equals 6? So we need to find f prime first. So f prime of x is derivative of cx is c plus derivative of ln cosine is 1 over cosine times the derivative of cosine, which is negative sine. So it is c minus, I can write it, sine over cosine is tan, or if you want to leave it like this, it's okay. But now f prime of pi over 4 is, I can obtain this by replacing x by pi over 4. If you check your calculator, pi over 4, tan pi over 4 is 1. So f prime pi over 4 is c minus 1. It should be equal to 6 according to the question. So c minus 1 is 6. This means c is 6 plus 1 or 7. So this is the value of c that makes f prime of pi over 4 equals 6. For what value of b is f prime of 1 equals to 3? Let us find f prime of x first. I have composition. Derivative is 1 over 3x squared minus 2 times ln b of times the derivative of 3x squared minus 2, which is 6x. Good. This is f prime of x. Well, I need f prime of 1. I replace x by 1, so I have 6 here. And 3 times 1, 3 minus 2, 1 times ln b, so I'll have ln b. So f prime of 1 is 6 over ln b. This should be equal to 3 according to the question. So now I need to solve this equation. Multiply, so 3 ln b would be 6, or ln b would be 6 over 3, which is 2. ln b equals 2, but I need b, so I can raise both sides to the base e, and then e cancels ln, and b would be e squared. Of course, if you know how to change from logarithmic form to exponential form, you can immediately get the answer. B equals e, which is the base of ln, to the power 2. Use logarithmic differentiation to find the derivative of this function. Well, remember, there are steps for logarithmic differentiation. The first step is to apply ln to both sides. So you say ln y equals ln all of this. And then we use the properties of the logarithmic function to expand the right-hand side. So ln y would be, now if we expand this, we will have 2 times ln x squared plus 2 plus 4 times ln x to the power 4 plus 4. I did it quickly because I did an example in the beginning of this section, step by step. Now I can find the derivative. So the derivative of ln y is y prime over y. The derivative of this is x1 over x squared plus 2 times 2x, and don't forget the 2 outside, plus there is a 4 here, 1 over x to the power 4 plus 4. Derivative of x to the power 4 is 4x cubed, and there is a 4 outside. So 2 times 2, or let me immediately now write the final answer, which is y prime equals, I multiply both sides by y. So y prime would be equal to 2 times 2 is 4x over x squared plus 2, plus 4 times 4 is 16x cubed over x to the power 4 plus 4 times y. But y is x squared plus 2 to the power 2 times x to the power 4 plus 4 to the power 4. This is the derivative of this function. Again, use logarithmic differentiation. So ln y equals ln all of this. Let me do this step by step. Now expand the right hand side. So I'll say ln e minus x cosine 2x minus ln x squared plus x plus 1. And now here I have product. So I can write it ln e to the power negative x plus ln cosine square x minus ln x squared plus x plus 1. And finally, I can bring negative, this ln cancels e, so I'll have negative x, and I can bring the 2 outside, so I'll have 2 ln cosine x and then ln x squared minus ln x squared plus x plus 1. This is ln y. We expanded. Now we find the derivative. Derivative of ln y is y prime over y. Derivative of negative x, negative 1. Derivative of 2 ln cosine is 2 times 1 over cosine x times the derivative of cosine, which is sine x. This 2 is the one here, okay? Minus 1 over x squared plus x plus 1 times 2x plus 1. Derivative of x squared plus x plus 1. So that's it. So y prime would be all of this. I can write this tan x, if you like, minus 2x plus 1 over x squared plus x plus 1 times y. And what is y? This is y. E to the power negative x cosine square x over x squared plus x plus 1. And this is the derivative of y. Apply logarithmic differentiation. Ln y equals ln square root. So I can write it to the power half and I can take half out. And then I write ln x minus 1 minus ln x to the power 4 plus 1. And now I can find the derivative. Y prime over y equals half times derivative of ln x minus 1 minus derivative of ln x to the power 4 plus 1. 4x cubed is the derivative of x to the power 4. So y prime would be this one times y, which is square root of x minus 1 x to the power 4 plus 1. And that's the derivative. Well, also logarithmic differentiation can be used to find the derivative of a function to function power x to the power 1 over x. There is no way to solve this problem except using logarithmic differentiation. So actually there is another way. I will write it down. So ln y equals ln x to the power 1 over x, and then you bring 1 over x outside. And now the derivative of ln y is y prime over y, and the derivative of this is a product. Derivative of 1 over x is negative 1 over x squared times ln x plus 1 over x times derivative of ln x, which is 1 over x. And finally, y prime would be, I have here negative ln x over x squared plus 1 over x squared times x to the power 1 over x. Of course, you can add, can write it 1 minus ln x over x squared times x to the power 1 over x. The other way, you can write x to the power 1 over x. You can write it e to the power ln x to the power 1 over x, because e cancels ln and you go back to x to the power 1 over x. And now you can take 1 over x outside the ln, and now you can find y prime. It is e 1 over x times ln x times the derivative of 1 over x ln x. Okay, and the derivative of 1 over x ln x is this one, or this one, or this one. So you can write it 1 minus ln x over x squared, and you get the same answer. So here, for example, if you want to solve it by the second way, you can write it e ln x sine x, and then you write it e sine x times ln x, and y prime would be derivative of this, which is e to the power sine x times ln x times the derivative of sine x times ln x, which is a product. Derivative of sine x is cosine x ln x plus sine x times the derivative of ln x, which is 1 over x. So I just write it sine x over x, and that's the answer. Or you can use logarithmic differentiation. Let me use logarithmic differentiation here. So ln y would be equal to ln sine x to the power ln x. And now you bring ln x outside times ln sine x. Note now that this is product, not composition. So derivative of ln y is y prime over y. And the derivative of this product rule, derivative of ln x is 1 over x times ln sine x plus ln x times derivative of ln sine, which is 1 over sine x, times derivative of sine, which is cosine. So I can write finally y prime equals ln sine x over x plus cosine times over sine. I can write it cotan, okay, cotan x, all of this times y, which is sine x to the power ln x. Let me solve this using the other method. So I can write it ln x. I can write it e to the power ln, and I write the function ln x to the power cosine x. You can cancel e with ln and go back to the function. All right, and now I can write it. I can take cosine outside, so I'll have cosine x times ln x, product of two uh, times, yeah, you bring cosine here, so I'll have ln ln x. Okay, if you bring cosine outside here, you still have ln ln x. Good. So now I find the derivative. Y prime would be derivative of this is e times cosine x times ln ln x times the derivative of this, which is product. Derivative of cosine is negative sine x times ln x, okay, plus cosine x times the derivative of this, which is 1 over ln x, times the derivative of ln x, which is 1 over x, okay, outer function, then the derivative of the inner function. So that's it. That's y prime. Okay, you can just write here cosine over x times ln, or you keep it like this. That's the final answer. Try to solve it with logarithmic differentiation and make sure that you get the same results. Okay, here implicit differentiation. To find y prime, we find the derivative of this equation with respect to x. The derivative of y is y prime. This is ln, so the derivative is 1 over x squared plus y squared. Derivative of x squared is 2x. Derivative of y squared is 2y times y prime. This is implicit differentiation. Cross product, so y prime times x squared plus y squared equals to 2x plus 2y y prime. If you remember, we keep all terms with y prime in one side. So I bring 2y y prime to this side. I keep 2x here. And then I take y prime common factor. So I have x squared plus y squared minus 2y. And then I divide by the coefficient of y prime. So this would be y prime. Again, find y prime. But here I have x to the power y function to power function, y to power function to function. So I don't have a rule to deal with this problem. I need to use logarithmic differentiation, or I can write x to the power y as e ln x to the power y, and y to the power x as e ln y to the power x. And then I take y here and I take x here. So I can do it like this. And now I can find the derivative. Derivative of the left-hand side is e y ln x times the derivative of y ln x. Derivative of y is y prime times ln x plus y times the derivative of ln x, which is 1 over x, equals e to the power x ln y times derivative of x ln y. Derivative of x is 1 plus x times derivative of ln y, which is 1 over y times y prime. Now I need all the terms that has y prime. So this one y prime times e to the power y ln x times ln x, okay, plus y e y ln x over x, expanding, plus EX ln y plus EX ln y over y xy prime. And I take y prime to this side, okay? I can also get rid of xy multiplying the equation by x times y, multiplying both sides by x times y. So, and take y prime to the other side. So here I have x, y, y prime, ey ln x, okay, minus. I bring this term to the other side and multiply by x times y. But y will be cancelled with y. So I'll have x squared y prime ex ln y equals. I have this term here, but I will multiply by xy. And this term, I take it to the other side, but I will multiply by xy. X cancels with y, and I'll have y squared ey ln x. So I can take y prime as a common factor and write y prime as over the coefficients of y prime here. xy ey ln x times ln x minus x squared ex ln y. So this would be the answer. Now we go to the derivatives of the inverse trigonometric functions. Remember, d by dx of sine inverse u is 1 over square root of 1 minus u squared times u prime. So f prime of x would be 1 over square root of 1 minus 5x squared. So 25x squared, 5x all squared. It will give you 25x squared times the derivative of 5x, which is 5. Also secant inverse. D by dx of secant inverse u is 1 over u times square root of u squared minus 1 and then times what? U prime. So just apply the formula. G prime of x would be 1 over u, which is e to the power x, times e to the power x squared, which is e to the power 2x. Okay, because you multiply the powers. Minus 1 to the power 2u prime, which is ex. Cancel ex with ex, and the final answer would be this one. Tan inverse. Well, d by dx of tan inverse u is 1 over 1 plus u squared times u prime. So u here is square root of x minus 1. So y prime would be 1 plus the square root. When you raise it to the power 2, it will disappear. And u prime is the derivative of the square root. So it is 1 over 2 times the square root of x minus 1. Well, here 1 minus 1 cancels, and I have 1 over x times this. So the answer would be like this. This is the derivative. This is y prime. Same formula, but u is x squared. So 1 plus the square of x squared, which is x to the power 4, and then the derivative of x squared, which is 2x. That's the formula. 1 plus u squared times u prime. Now here I have tan inverse x to the power 2. So I use the power rule. 2 times tan inverse x to the power 1 times the derivative of tan inverse x, which is 1 over 1 plus x squared. So that's the answer. If you want, you can write it 2 tan inverse x over 1 plus x squared. That's the derivative. I have product. So h prime of x would be derivative of sine inverse x, which is 1 over square root of 1 minus x squared times ln x plus sine inverse x times the derivative of ln x, which is 1 over x. So that's the derivative. Here I have composition. Derivative of ln is 1 over arctan is tan inverse times the derivative of tan inverse, which is 1 plus u square. U here is t to the power 4. When you raise it to the power 2, you will have t to the power 8 times the derivative of t to the power 4, which is 4 t to the power 3. So that's the final answer. F prime of z. I have e. So that's the derivative of e times derivative of the power of e, sine inverse, which is 1 over square root of 1 minus u square. So z square raised to the power 2 would be 4. And then times the derivative of z square, which is 2z. That's the derivative. Y prime is product. Derivative of x is 1 plus x times the derivative of sine inverse, which is square root 1 over square root of 1 minus x squared plus derivative of the square root is 1 over 2 square root 1 minus x squared times the derivative of 1 minus x squared, which is negative 2x. Okay, 2 cancels with 2. And I have x over square root minus x over square root. They cancel each other. And y prime would be just sine inverse x. I have composition. Derivative of cosine inverse, remember, d by dx of cosine inverse u is negative 1 over square root of 1 minus u squared times u prime. So it is 1 minus sine inverse t to the power 2, and there is a negative sign, times the derivative of sine inverse, which is 1 over square root of 1 minus t squared. And you can keep it like this. You can leave it like this. That's it. Thank you very much. I hope you had enough exercises about this section.